Okay, so what we've looked at so far is that we've looked at how to create a new account on ContinuSec. We've looked at how to create an access rule for that account. And then we've used that access rule to create our first verifiable log and our first verifiable map. And we added some entries to those, and we did certain other operations such as verifying inclusion proof of those entries. Now when we added those entries, we added them with the format raw data. And if you recall, there are some other options in the user interface for adding entries as well. And one of those other options was to add as JSON. And in this tutorial, we're going to talk a little bit about some of the issues in adding JSON and how we address some of those challenges. JSON is a really useful format for handling structured data. There's a lot of support in pretty much every major language for parsing and writing out JSON. But one of the challenges that we hit with JSON in the context of a verifiable data structure is how we can consistently get a hash for data that may be represented in JSON. And some of the reasons why this is a challenge is a JSON represented, written out or serialized as a string, there is not one canonical format for doing so. For example, JSON may contain white space around elements that are not significant from a processing point of view, but would be significant if we were to naively hash the string that the JSON is represented as. There are issues around normalization of the Unicode characters that may be within JSON. There are issues in terms of how integers versus floating point numbers are handled. And so to counter some of these, we've turned to some technology or a protocol released by Ben Laurie late in 2015 called objecthash. And what objecthash does, it defines a method for taking an arbitrary data structure, whether it's in JSON or whether it's expressed in some other format, and describes a mechanism for creating a hash for that data structure. And the way it does that isn't by serializing it out to a specific common format, but rather it's by relying on your libraries to process the data structure that you already have parsed in memory, and it defines how you take that data and feed that as input to the particular hash function that you're using. And so the page that I'm displaying here is in the ContinuSec documentation, and what this does, it describes the subset of objecthash that ContinuSec uses for JSON processing if you choose to use this feature. And so what this does is it describes how one hashes a number, which essentially describes how we convert a number, whether it is floating point or an integer, because JSON does not distinguish between the two, but how we convert that into a string of data that we then use for creating a hash. It describes how we handle booleans, how we handle strings, and that we normalize them using Unicode normalization format C, how the null value is handled, how we handle lists by prepending them with a character and then taking the object hash of the constituent parts. And then finally, how we handle a map, where a map may have many keys and values, and how we will prefix that with a D, and then we will take the set of key value pairs, hash them each individually, concatenate them and append them, and the particular order in which we do that. I'm not going to exhaustively talk through all of the information on this page. Go back to this page for reference, and we highly encourage you to use one of the client libraries that we have provided where we have an implementation of objecthash for you. But for now, let's look at how we can use objecthash and how objecthash relates to log processing. So let's go back up to the top and we'll go to our console. And in our console, we'll go to our shell. And in the shell, we'll use the demo access rule that we created earlier. Let's create a new log. Let's call it objhash. And in this log, let's add an entry. Now I have an entry that I prepared earlier. Here, let's add this entry here. It's a little bit of basic JSON with a dictionary with name, Adam, and a particular date of birth. And I'm going to click Add as JSON. We'll talk about add as reductible JSON in a separate tutorial. So add this as a JSON object. And what this is actually doing on the server is it uploads this into the log, but when it's calculating the leaf hash for the entry in the log, the leaf hash that we return here is not the Merkle tree leaf of this as a string, but rather we take the object hash for this JSON data and we use that as input to the Merkle tree leaf function. Let's add a second entry and then we'll go and view the data that we have in the log to see how that plays out. So I add a second entry, similar format, name, date of birth, and let's add that as JSON as well. And again, in this case, we're not adding the string, rather we are uploading it as a JSON object. We're taking the object hash of that object, and then we're using that object hash as the actual entry in the log itself. So if we get back to our log and we fetch the entries in the log, let's go fetch entries, we would expect to see 2 entries come back. So let's first fetch that as JSON. And we hit fetch as JSON and we see 2 entries come back. We see name Adam, date of birth, name Susan, date of birth, as expected. And we can see the, because we have a small number of entries here, we show a diagram and we can see the leaf hash for entry 1 is the /RL VD for the second. But if we were to instead fetch this as raw data, so let's say you had a generic auditor for this log that didn't care if the data was raw, didn't really care anything about the format of the data, it could fetch this as raw data where what we're seeing here isn't the actual JSON that we're saying, but rather what we're seeing here is the actual object hash for that JSON. And so what that means is that someone that is checking the consistency of a log or someone that is auditing the correct operation of the log doesn't need to understand the format of the data within the log to verify that correct behavior, whereas clients that do understand and know that the data in here is JSON can choose to fetch that as JSON and get the data that they want. Regardless of whether we fetch that as JSON or as raw data, you note that the root hash for the log and the hash for the entries does not change. So the hash, the /RLA we see here, is precisely 0 with this non-base64 encoded object hash added to it. We get that same data back. And the neat thing about using object hash instead of just purely using the string JSON is if we were to say do an inclusion proof on this log. Let's say that a client has received a particular record and they wish to prove that it is included within a log. They don't know what format the data was in the log as. So let's say we have our string from before. This is the data we had in the log that we'd added to the log. But let's pretend it was actually in a different order. Let's pretend these keys were in a different order. Maybe there's some spaces in there. Remember, the client may have received this data elsewhere. It doesn't necessarily need to be in the same format. And if we were just naively requesting a proof of this as a string, it would of course fail because the data would not be in the log. But if we request a proof inclusion of this as a JSON object hash, then the server is able to take the same object hash of this data, because the representation, the precise serialization doesn't matter, and then return the leaf index, that is, which is of course index number 0, and then return the information amber here, which is the other data we need to make the inclusion proof for the root hash. So that's a really quick demonstration of how we can use object hash to handle JSON data. One of the interesting future sections we have talks about how we can handle redactable data, which takes advantage of some of the features that we have here to provide a partially redacted JSON or object hash entry back.